Today's topic will be MAST, the JWST archive. So the Mikulski Archive for Space Telescopes, that's MAST, hosts science data from a lot of NASA missions spanning 50 years of exploration, including, lately, James Webb Space Telescope. We're based at the Space Telescope Science Institute in Baltimore, and we provide open data, user tools, and services to enable forefront astronomical research, data science, and education. Today you're going to learn a few things. The first is to use MAST's web-based tools and also application programming interfaces. You'll subscribe to and search for JWST data, identify data products of interest to you, efficiently retrieve those products of interest, and learn how to create digital object identifiers for data you publish. So here's the overview. It's a 2-hour session in 3 parts. First is Introduction to MAST, which is a summary of user resources and also click-along demos of our web-based searches and so on. We'll also have a following session on the API tutorials, that is to say, scripted MAST queries with the notebooks. There'll be a couple of primary examples, querying and retrieving large numbers of data files, and then searching for time series spectra of exoplanets. There are instructions for the notebook installation, which I think you've already seen. It's on GitHub. And following that, there'll be a demo of working with digital object identifiers, that is, creating them and adding them to a manuscript. First of all, this slide talks about user resources for you, a lot of links to documents and so on. In the PDF that you can download of these slides, these links, hyperlinks, should be active. I'm not going to read all these to you, but it's just a matter of reference. In fact, a lot of this presentation is just to give you an idea of where are the resources, where can I get help on a particular topic. So this is sort of the high-level summary, and I'll try and show you an example of the documentation a bit later. There's some vocabulary that's important. These terms come up time and time again in the documentation and in the demonstrations today. Some of you may know these words, others may not. The program ID, or known in MAST as the proposal ID, is just a numeric identifier of the science program for which the observations were obtained. The science programs are led by investigating teams from the community, and those teams are awarded time based on competitive peer review. There's observations with a capital O that have a special meaning in MAST. They're really placeholders for collections of all data products that were generated for a given exposure of a target. It also includes ancillary data of other things, GuideStar products and so on. But all those are bundled up underneath the thing we call observations. Now, the data from the spacecraft come in a fairly raw form or uncalibrated. And these are processed by a pipeline in various stages, and the science data are ultimately calibrated to physical units. And ultimately, related calibrated products are combined. So these are, these various stages, or we call them levels typically in MAST. There are recommended minimum recommended products. These are a subset of all that we consider under observations, big O observations. These are calibrated and combined products and are the most appropriate for immediate science analysis. These are typically only a small fraction of all products that are available. And finally, there's exclusive access data. These, when data come off the telescope, they are typically initially available only to the investigating team for a period of time. And that exclusive access period expires within a year, after which the data become public. Here's another eye chart for you. This is a table of the various web interfaces that MAST offers, user-facing interfaces. I'd encourage you, if you haven't already, to bring up in your browser the mast.stsci.edu, which is really a shortcut. There'll be a redirect to the portal. I'll be talking about some of these interfaces. Others, for lack of time, I can't really go into, except Thomas later will talk about the DOI portal. Now, in getting started, just keep this in mind. The web browsers that work are recent versions of Firefox, Chrome, and Safari. Internet Explorer and Edge typically do not work very well. Now, this next point is crucial. Please be sure, a lot of you, including me, have blockers for pop-ups from various annoying commercial sites, but please do allow pop-ups from your browser for the domain mast.stsci.edu. Failing to do that will mean that the portal interface will fail silently. Now you can log in. There's a little place for you to do that in the portal. You don't need to log in to get public data, but if you want exclusive access data, like say you're a collaborator on a JWST program that's active, you'll need to log in so that you can be authenticated to the system. You'll also need that even if you're not a member of the PI team, if you want to create subscriptions to data products and to view notifications. As for authorization, if you're a member of you can't access exclusive access data unless you're part of the proposal team and the PI grants access to you. So that's a matter of being authorized. Logging in authenticates, authorization happens separately, and the PI can do that for you. And finally, if you actually want to retrieve protected data from MAST using a API, an application programming interface, then you'll need a MAST token. And Jenny will talk about that in her one of her demonstrations. This is just a finding chart for the MAST portal. It's what it looked like after a successful search. And you can see various things at the top. There's a search panel. There's an action bar that you can do various things with here. In the middle, in the lower part, you'll see a filters panel where you can select only subsets of what appears in the middle, which is the results table. And on the far right, there's our AstroView tool. And in fact, that shows a background of a sky survey superimposed upon which is the outlines of apertures for exposures from the various missions that MAST offers in that location. So we talked about big O observations here, and this is more detail on that. A variety of data products are rolled up under observation, and for JWST, they include science products, that is all levels, all processing levels, raw, intermediate, calibrated, combined, and ancillary products. This includes GuideStar products that are contemporaneous with science observations, associated products, visualizations, and all that, and preview products for image visualization of science products. This is sort of represented here in the figure on the right, where things in the red square are the things that are rolled up under observation, level 3 and all the other levels and so on. From here, you can get to, it's possible to get to other data beyond that, the engineering database and calibration reference files, which is a less common case, but people sometimes are interested in that. There's a link here for MAST data product types, which will help you understand the semantic contents of what all these files mean. So what's the workflow? Typically what you're doing is querying and retrieving data from the portal in the following way. You compose and execute a search. And for that, you choose a collection and then conduct a search either by target coordinate or some advanced search. You can place the objects of interest in what we call a download basket. This is, analogous to Amazon or any other commercial site these days. And select in detail the products you actually want to download. And there are various ways to filter on that. Then you just choose a method for downloading the data, click the button, and off you go. When you're downloading data, there are a few options to keep in mind. There's a direct streaming download from the results table. I'll show you that in the demo, but it's very convenient. One click and you got something coming to you. The cons are that it only selects the minimum recommended products, not the whole set. And if you select a lot of things, it can be very slow for large data volumes. In fact, there's actually a limit of, 50 gigabytes or so. You can go to the next step of complexity, which is to choose a bunch of products to put in the download basket, and then down select, figure out which exact files you'd like to download, and then download a bundle there, which is also streaming. So it can be slow for large data volumes, but it's also fairly convenient and a little more specific to your needs. There's a curl script, which is we're a fan of that. It's fast, robust, great for large data volumes, but it's a little less direct. I mean, what you're doing is taking the bundle of files that you say you want. There's a process in the background that builds a bash script with a bunch of curl commands in it, and when you run that file from a shell on your machine, it'll fetch the files one by one. But it's robust. And then there's batch retrieval or staging, which is the data are staged on a local on an archive disk for you to fetch by FTPS, although you'll need a third-party client for that. And I would just mention that the hard media option really isn't well supported for JWST, so I would not recommend selecting that. A few more tips and pointers. Note the distinction, and here there's a select a collection thing, a drop-down, which I'll show in the demo, but basically there's a bunch of things you can select on. And when you're searching by target name or position, it returns the observations, big O observations that include all the files. If you search by instrument keywords, what you have in that, and this keyword thing is second from the bottom entry, and that allows much a richer set of metadata upon which to select the types of data of interest to you. And in fact, there are some kinds of data that really aren't available unless you do an advanced search. The problem is that it returns only the highest level science files, individual files, rather than the whole kit and caboodle with the observations. And so generally, the uncalibrated files are not discoverable this way. Just bear that in mind. Observations may link to hundreds or even thousands of files. So I highly encourage folks to use filters in the download basket to select the things they really, really want. Not many people would be interested in the GuideStar files, I suspect. And because of that, it's also, again, it's best to fetch a download script to retrieve very large volumes of data. Finally, you'll need a token.